And welcome to the Smash News Network, least busted name in news. We'll be talking about the ionosphere, the electron flux, and our bonus features. Let's do it. Satellite charging hazards. We see some satellite charging hazards here over the Central Pacific. Some surface charging could cause some communications problems. Don't be surprised to see some issues if you're looking at satellite data. Electron flux is at high levels. That's a one-year chart to put it in context. Here's a 3-day chart. And it looks like the GOES 17 is about to go back into warning levels. The GOES 16 already at warning levels. And here's a relativistic electron forecast expecting a continued high level of electron flux. Let's take a look at the total electron content forecast, which is basically the area in between your GPS satellite and your handset, the electrons in the plasmasphere, and the lower Van Allen belt. So this will show you where GPS errors are most likely to occur. Some significant errors over North America. That's your total electron content forecast. Next, the ionosphere. We're going to show you that as well. This is just a diagram to show you where it is. The F layer is located at about 300 kilometers of altitude. Here's your ionogram. All right, so here's your ionogram. Some pretty wild swings here in the vibrational frequencies overhead, in places like South America especially. The location of the weakest point in Earth's magnetic field, located right about here, now over the South American continent, the South Atlantic anomaly, maybe about to be renamed the South American anomaly. Let's look at the anomaly gram for the ionosphere. So here's the anomaly gram. Continued low-frequency anomalies over mainly the southern hemisphere during southern hemisphere summer, and some wild swings. Some wild swings there in the anomaly gram, showing high-frequency anomaly in blue, low-frequency anomaly in red. It's the anomaly in megahertz from the 30-day median. Here are the latest images. That's 12 o'clock universal time. There's the ionogram. And there's the anomalygram, looking pretty normal at the moment. Here come some more bonus features. Starting with the ground-based solar observatory in Cerro Tololo, Chile. Lots of filaments on the Earth side of the disk. Coronal mass ejection warning simply remains, folks. Although we've seen some, we do have a high chance of some larger flares happening here, especially as these two sunspot groups, 2929 and 2930, are approaching the western limb. Don't be surprised to see additional solar flares here on the earthly side of the sun. Here's a NASA GOES 16 SUVI imagery. Did catch a small prominence there. Down here in the southeastern limb. Let's check and see if any sunspots have risen, as we do see some activity rising in the east. It didn't look like it when we did show prep. Let's see if the bonus features are showing anything. I don't see any umbrae. So at the moment, those are not sunspots. The rest of the sunspot groups have remained largely stable or degraded. We might be down to only 4 named sunspot groups. There's the colorized magnetogram. Most likely place to see major flares, in my opinion, is these two active regions here, 2929 and 2930. If you enjoy the content, please consider becoming a member of the Smash team, as we're paid just this side of nothing to put the videos on YouTube. Also, please press share, press like, subscribe, etc. Tell your friends and foes about us. Congratulations on realizing the channel exists. We'll close out the bonus features section with this spectacular 171 angstroms imagery from the SDO. There is a C-class solar flare here, and that's 24 hours of data. 171 angstroms, my personal favorite wavelength. Thanks for tuning in, folks. And may that solar wind be at your back.